Hey, what's up, guys? Big video coming at you here. I'm going to solve problems 5, 6, 8, 10, 12, 13, 14, 17, 21, 22, and 23 from the review sheet. I'm also going to talk about my thought process and what we need to know to solve these and what we need to do for our justifications. Again, it all comes down, this whole thing comes down to justifications and definitions, right? Do we know our definitions like the back of our hand, right? You can listen to me talk about them all day long, every day, but until you start thinking of them yourself and start challenging yourself to think of them in your own head, it's not going to mean as much. So as you're doing these problems, think about the definitions that you need to be true. I'll include that Quizlet link just so you can practice those definitions and get them down. Once you have the definitions down, this isn't too hard, okay? Without the definitions, it's really, really difficult, okay? And we'll just hopefully work towards mastery of conceptual understanding. Okay, the first problem here says f of x equals x squared minus 6x plus 2. Find the value c that proves the mean value theorem on the interval -2 to 4. Okay, so when I see this, I see, okay, I'm supposed to find c, and I'm supposed to prove the mean value theorem. Okay, we need to know the equation for the mean value theorem, which is this. So that's our formula that we know and love. Okay, and now we just have to apply it to this particular problem. Okay, the a and the b here come from our interval -2 to 4. Right, just put them in alphabetical order. -2 is our A, 4 is our B. So I'm going to go ahead and, again, I'm going to solve for what f prime of c. That's not going to be my final answer, but it's important to figure out f prime of c before I figure out the value c. Okay, so now I just have to do this thing by hand, and it can be a little bit tricky. So f of b here is going to be f of 4. I'm going to go ahead and calculate f of 4 because I don't have a calculator here. I have to do that part by hand, which again can be a little bit tricky. So here's what we have, f of 4. That's going to be 4 squared minus 6 times 4 plus 2. 4 squared is 16 minus 24 plus 2. 16 minus 24 is -8. It's -6. Make sure you're very careful with all of your signs here. -8 plus 2 is most definitely -6, not +6. So, okay, so that's my f of b. That's f of 4. It's -6. Now I have to subtract f of a. Okay, f of a then will be f of -2. So once again, I'm going to do that work on the side here. Okay, -2 squared is 4 plus 12 plus 2. 4 plus 12 is 16. 16 plus 2 is 18. Notice it's -6 minus 18, even though the 18 was positive, right? Because this is a subtraction sign, it stays there. Okay, over b minus a, which is 4 minus -2. I'm going to change that 4 minus -2 to 4 plus 2. Okay. Now I'm going to simplify this thing down. -6 minus 18 is -24. -24 divided by 6 is equal to -4. Okay, so I found f prime of c. The mean value theorem guarantees that f prime of c must equal -4. Okay. But again, that doesn't give me the value c. To find that, I have to also think about f prime of c in terms of the function given. So first I'm going to find f prime of x. And I'm going to rewrite this as f prime of c. Okay? Pretty easy to do there. So now I have f prime of c equaling 2c minus 6, and I have f prime of c equaling negative 4. I'm going to set those two things equal to each other. And I get my final solution of c equals 1. Just take a look. Your c needs to be between a and b, and 1 is between negative 2 and 4, so I know I'm good. Okay, next problem. F of x equals 3x squared minus 18x plus 10. Now, a different type of problem here. I'm supposed to find the absolute maximum and absolute minimum values of f on the interval 1, 4. Okay, so absolute maxes and absolute mins. Okay, what we need to know about those is because of the extreme value theorem, we know that those have to occur at either endpoints or critical points. And we need to test all the endpoints and critical points in f of x and see which one makes the biggest value, which one makes the smallest value. Again, to organize here, I like to make a t-chart of x comma f of x. And again, what I like to do is, I know I'm going to have to test my endpoints. I already know what those are. The left endpoint is 1, and the right endpoint is 4. I like to write those down first at the top of my chart and at the bottom of my chart. So it just as a reminder to myself that I'm only going to test any critical points that show up only if they're between 1 and 4. So if I get a critical point at x equals 5 or x equals 0 or x equals 10, I'm not going to test those because they're not on the interval. Okay? That's just a way to keep track of it so I don't make that mistake, which is an easy mistake to make. Okay, so I've got my endpoints ready to test. What I need to figure out next is if I have any critical points and if they're on that interval. So critical points, by definition, is when f prime of x equals 0 or f prime of x is undefined. Let's go ahead and find f prime of x. And I want to set my derivative equal to 0. Solving that, I get 6x equals 18, and I get x equals 3. 3 is on the interval 1, 4, so I will test 3. Those are the only 3 x values I have to test, and I know that my absolute max and my absolute min will be lying somewhere within those 3 choices. Now I just have to plug them in and solve. Okay. Now notice, based on our table here, right, we want to find the absolute max and absolute minimum values of f. So I'm plugging these answers, 1, 3, and 4, I'm plugging them into f of x, not f prime of x. Okay, because I want to find the maximum values of f. So let's go ahead and start working this out. And again, we have to do this without a calculator, so just do it carefully. 1 squared is 1, 3 times 1 is 3, minus 18 plus 10. 3 minus 18 is negative 15, plus 10 equals negative 5. So I know that's my first one. I recorded on my little t-chart there, so I have an easy place to look at the end. I don't have to look all over my page. Okay, next I'm testing 3. Three squared is 9. 9 times 3 is 27. I don't know what 18 times 3 is off the top of my head. I'm just going to do some long multiplication here. 3 times 8 is 24. 3 times 1 is 3 plus 2 is 5. So I got minus 54 plus 10. Now I have to do 27 minus 54. Again, I don't know what that is on the top of my head, but I see I have opposite signs here, so I need to subtract those two numbers. I'll do that over here. 54 minus 27. I'm going to go ahead and borrow. 14 minus 7 is 7. 4 minus 2 is 2. Okay, but here's where we need to be careful. I saw some mistakes on this on the last test. Right, 27 minus 54 is a negative number. So even though I got 27 for my solution, I need to write negative 27. There we go, negative 27 plus 10 is negative 17. Okay. Lastly, I need to check f of 4. Four squared is 16. 16 times 3 is 48. Minus 18 times 4, I need to do that. 32. 4 times 1, 72. 48 minus 72, I'm going to write that as 72 minus 48. 12 minus 8 is 4. So I get 24. But again, analysis here shows me that that needs to be a negative 24. Okay. And negative 24 plus 10 is negative 14. Okay. So now I just have to report my absolute max and my absolute min. Because of the wording of the question, right? If we scroll up here, I want the absolute maximum and absolute minimum values of f. That means I'm reporting the f column here. If it said report what x value do those occur, then I'd report the x value. Okay. So what I can say here is, let's start with the absolute max. And the biggest number here is negative 5. And then for the minimum, then would be negative 17. That would be the absolute minimum. And those are my two answers. Okay, next question. Okay, so this is a table question. Here I have my values, x values and f of x values. Notice it says f of x is a differentiable function. So that means all my theorems apply. I can use the MVT, that requires differentiability. I could use the IVT, that requires continuity. I could use the EVT because it requires continuity. And differentiability implies continuity. So it says, explain why there must be a value c, where negative 6 is less than c is less than 0, such that f prime of c equals 3. Okay, so whenever the table has a function, and they're asking a question about a derivative, right, equaling a certain thing, then we know it's going after the mean value theorem. So what I want to do here is, first off, think about the conditions required for mean value theorem, which is differentiability. So I got to say that first. I say that first because it's what I always forget to do. So I start with, since f is differentiable, that's one of the things I need. Okay. Now I'm just going to kind of restate the prompt here, and I'm trying to show that f prime of c does equal 3. I have to show that using my equation f of b minus f of a over b minus a. And if I can do that, then I can say that this is true because of the MVT. Okay. So since f is differentiable, there must be a c. Oops, I wrote that wrong. Okay, so again, now I need to get into my f of b minus f of a over b minus a, okay? And again, the question tells you the values of a and b, right? It's written with as a compound inequality here. But again, the one on the left is a, the one on the right is b. So I'm going to do f of b, so f of 0 minus f of negative 6 over 0 minus negative 6. I just changed that to 0 plus 6. Okay, and then reading the table, f of 0 here is 8. Minus f of negative 6 is negative 10. 18 divided by 6 is 3. Again, it needs to match right here. If you get a number that doesn't match there, then you know something's wrong, right? Maybe you were looking at the wrong interval, or you had your A's and B's mixed up or something like that. Okay, so I proved, and again, you need a difference quotient here, and it needs to equal 3. And then we can say because of the MVT. Question 10 is from the same table. But what I want you to notice about question 10, everything kind of looks the same as question 8, except for one tiny little difference, right? I just have f of c equals 9, okay? The table is of f, the question is about f. So this is not a mean value theorem question, this is actually an intermediate value theorem question. And if we look back at our table here, I should see when x is between 0 and 4, are we for sure guaranteed to have a y value equal to 9? Well, looking back here between 0 and 4, f of 0 is 8, f of 4 is 10. So as long as this function is continuous, to go from 8 to 10, I have to go through 9. But I need continuity. Notice I never said f was continuous, I said f is differentiable. So I need to show that differentiability implies continuity first. Then it's just an IVT like we had on our very first test. So I need to state that since f is differentiable, f is continuous. Okay. Also, so just be careful when you're looking at that, right? Don't start doing the mean value theorem. In fact, if you do, you're not going to get 9 as a solution anyways, right? That's an intermediate value theorem question. All right, next problem. Here we have a function, a third x cubed minus x squared minus 35x plus 4. On what intervals is f increasing? Again, here is the definition that you need to know. Right? That starts the whole thing. F is increasing when f prime is positive. That's the definition we need to know. So to figure out where f prime is positive, I have to first figure out where f prime is equal to 0, and then do a number line test. So finding f prime here. 3 times the third is 1, so I have 1x squared minus 2x minus 35. And again, I'm going to set this equal to 0. Right, and I see the two numbers that I'm looking for, they have to multiply to negative 35, but add to negative 2. That's a -7 and a +5. Little RS method shortcut because my lead coefficient is a 1. So that gives me two solutions, x equals +7 and x equals -5. So that's when f prime of x equals 0, right? Because that's what I did. I found f prime of x and I set it equal to 0. So we're going to make a number line. Make sure you name that number line as f prime, because that's what we're testing. Because we want to figure out where f prime is positive. So I'm going to plot -5 on the left and 7 on the right. And now I just need to test numbers around them. I know f prime is 0 at these two places. But what about -6, right? Something to the left of -5. Again, I plug it into the factored form. I'll do my test over here. -6 minus 7 is a negative number. -6 plus 5 is a negative number. A negative times a negative is always going to make a positive. Now I'll test 0. 0 minus 7 stays negative. 0 plus 5 is now positive. A negative times a positive is a negative. Lastly, I'll check a number like 8. 8 minus 7 is now a positive number. 8 plus 5 is a positive number. A positive times a positive is a positive. Okay, now I just have to report the regions where f prime is positive, right? So I have the region on the left, right? So I'm going to say f is increasing. On the interval -infinity to -5, union 7 to infinity. So those are that's my interval. My justification then is because that's where f prime is positive. So whether it's an f increasing or f decreasing problem, we start at the same. We do the derivative, we set it equal to 0. We do our sign test. And if it's an f is decreasing, I report the negative. If I'm looking for f increasing, I report the positive. All right, next question. Okay, so I have this function here. I want to find the critical points of f. Okay, again, so my definition then, critical points, I need to know is when f prime of x equals 0 or f prime undefined. And again, those definitions, think of it as f prime equaling 0, not it equaling 0. Okay? And then I want to determine if it's a relative max, a relative min, or neither. I know a relative maximum is when f prime switches from positive to negative. A relative minimum is when f prime switches negative to positive. Neither is when f prime doesn't change signs. Notice I said f prime each time, right? You can rewind it to prove it. And that's because if I want to write good justifications, I want to speak clearly with good justifications in my words. Okay, so the first thing I have to do here is find f prime of x. And I want to set that equal to 0. Now, when I set this equal to 0, you're welcome to factor out a 3. Okay? Or you could divide by a 3. Okay? And the equation will remain true either way. I usually divide out the 3, so this time I'll show you what it looks like when we factor it out. Now I can do RS method on that inside. Again, what two numbers multiply to 12 but add to 8? That would be 6 and 2, both positive. So that gives me 2 solutions, only 2. Okay? Again, when I have 3 things multiplied together here equaling 0. So I ask myself, when does 3 equal 0? 3 never equals 0. That doesn't give me any solutions. The second term, x plus 2 equals 0 when x equals negative 2. X plus 6 equals 0 when x equals negative 6. Okay. So those are my critical points because I took the derivative and set it equal to 0. But I need to determine if they're relative mins, relative maxes, or neither. So I need to do a number line test just like I do for f increasing and decreasing. Again, it's an f prime number line. Make sure you make negative 6 on the left side with negative 2 on the right, because negative 6 is more negative than negative 2. And again, I'm going to test, right? And I can test in this factored form right here. Now again, this 3 is 100% always a positive number, because 3 is a positive number. But now I want to test maybe negative 7. Negative 7 plus 2 is minus. Negative 7 plus 6 is minus. I have an even number of negative signs, so I know that region is plus. Next, I'm going to check negative 4. Again, 3 is always positive. Negative 4 plus 2. Negative 4 plus 2 is negative. Negative 4 plus 6 is now positive. I have an odd number of negative signs, so I've got negative in the middle here. Then I can try 0, and all 3 of them become then positive, and I get a positive out here. So I want to analyze these 2 critical points I have. X equals negative 6, right? That meant since f prime is switching from plus to minus, that means my function switched from increasing to decreasing. That creates a max. So x equals negative 6 is a relative max. Again, because f prime switches plus to minus, positive to negative. Okay. X equals negative 2, then is the opposite. X equals negative 2 is a relative min because f prime switches minus to plus. And we're done. Next problem. This one says, on what intervals is f concave down? And again, I have to know my definitions. Now we know we know 3 different definitions for concave down. F is frowning, f prime is decreasing, and f double prime is negative. Because I'm dealing with a function here and it's really easy to get to f double prime, that's the one I want to use, right? Because I don't have a graph. If I had a graph of f prime, I'd look where f prime is decreasing. But again, just to remind myself, f concave down, that means f double prime is less than 0. Because I was given the function f, I'm going to have to do 2 derivatives here. So I'm going to find f prime first. 4 times 1/12 is 4 over 12, which is the same as 1 over 3. X cubed minus 3x squared plus 5x plus 2. That's f prime. I got to do 1 more derivative. Again, make sure you're labeling these as you're doing them. F double prime then would be x squared minus 6x plus 5. So now I want to figure out where something is positive or negative. I first want to figure out where that thing is 0. So I want to figure out where f double prime of x is equal to 0. So I'm going to set this equal to 0. And the 2 numbers that multiply to make positive 5 but negative 6 are minus 1 and minus 5. That gives me 2 solutions, x equals 1 and x equals 5. This is now an f double prime number line. I'm going to plot 1, and I'm going to plot 5. Again, I'll choose 0 for my left region. 0 minus 1 is negative. 0 minus 5 is negative. Negative times negative is positive. And I'm going to try 2. 2 minus 1 is now positive. 2 minus 5 is negative. It's a negative. I'm going to try 6. 6 minus 1 is positive. 6 minus 5 is positive. Positive. Again, I want concave down, so I want to report the negative region. I'm going to say F is concave down. On the interval 1, 5. Because that's where F double prime is less than 0. Okay, next question. Find the x values of the inflection points. Now again, I know inflection points from several different places. An inflection point is when I switch concavity on F. Right, go from smiling to frowning or frowning to smiling. I know on an F prime graph, an inflection point is when F prime goes from increasing to decreasing or vice versa. That doesn't help me here because I don't have a graph of F prime, I just have the function F prime. So the definition that I want to use here for inflection points is F double prime switches signs. So I need to get to F double prime, and I need to figure out where F double prime switches signs. So I'm going to figure out the zeros and then see where my signs switch. To get to F double prime here, I only have to do one derivative because I'm already at F prime of x. So F double prime here. The 4's cancel. So I'm left with 1x cubed minus 9x squared. And again, I want to figure out where this thing changes signs. So I got to figure out the zeros. To solve this then, I want to see that, okay, I can factor out an x squared from both. I'm going to have x squared, parenthesis, x minus 9. So I want to set both of these equal to 0. So x squared equals 0. I can do the square root of both sides at x equals 0. That's one of my solutions. And then x minus 9 equals 0 at positive 9. So those are my two candidates for inflection points. But I can't call them inflection points yet until I actually make sure F double prime switches signs. And really important to do that test here. So I'm going to plot 0 and 9. And I'm going to plug it into the factored form. So let's think about negative 1. Negative 1 squared is a positive number. Whether a number is positive or negative, when we square it, it always becomes positive. That's going to cause one of these 2 points to not be an inflection point. Okay, I plug negative 1 into x minus 9. Negative 1 minus 9 is negative 10. A positive times a negative is a negative. Now I'm going to try the number positive 1. 1 squared is still positive. 1 minus 9 is still negative. So nothing changes, and I'm left with a negative here. By the way, right now I can tell that x equals 0 is not an inflection point. All right, now I need to try a number to the right of 9, so I'll use 10. 10 squared is positive. 10 minus 9 is positive. So that means my only inflection point is right here at x equals 9. And I know that because F double prime switches signs there. So that's why we do the test. Just because it's a 0 doesn't necessarily mean it's an inflection point. Okay. Okay, now on to the graphs. We'll take a look at this graph here. First thing to know, we are looking at an F prime graph, the derivative of f of x on the interval 0, 5. F prime has horizontal tangents at x equals 2 and x equals 3. Right? We can kind of tell that by looking at the graph, but it's just letting you know that those horizontal tangents are at 2 and 3. Okay, the first question is, on what intervals is f increasing? And again, I need to know my derivative. F increases when f prime is positive. I have an f prime graph here, so I just want to report the positive regions. You can do this in one of two ways. You're allowed to say 0 to 2, union 2 to 4, or you can say 0 to 4. And the reason I chose those is because I know my definitions and I know my justification. Because that's where f prime is greater than 0. Those are my positive regions, right? Positive is anything above here. That graph will be positive, and the graph is of f prime, so that's where f prime is positive. On what intervals is f decreasing then? Well, anywhere we're below the line, that would be from 4 to 5. Because that's where f prime is less than 0. You don't have to write a lot here, but you do need to be specific. Don't say because that's where it's 0. Or sorry, that's where it's less than 0. Okay, C wants the x values of the critical points of f. Determine each one as a local min, local max, or neither. Critical points, again, is when f prime of x equals 0. We're looking at an f prime graph. I can tell that there are two zeros. There's one at x equals 2 and one at x equals 4. So those are my two critical points. Let's start with x equals 2. X equals 2 is neither a max or a min. Because if you notice, f prime doesn't switch signs. On the left side, f prime is positive. On the right side, f prime is positive. Even though that looks like a min, it's not a min of f. It's a neither point of f. Because f prime didn't switch signs. Okay, x equals 4. I notice that f prime is switching from plus to minus, left to right. So I know x equals 4 is a local max. And again, because f prime switches plus to minus. All right, lastly, inflection points. The inflection points, and again, it's when f double prime changes signs. That's what we used earlier in the video. But here I want it in terms of f prime switches from increasing to decreasing or vice versa. Okay, I'm looking for those minimum maximum values of f prime would give me the solution there. So I'm going to have an inflection point right here, because f prime switched from decreasing to increasing. And I'm going to have an inflection point here because f prime switched from increasing to decreasing. It's not about changing plus to minus, it's about changing increasing to decreasing. Okay. Let's say x equals 2 and x equals 3 are at the inflection points of f, because f prime switches from, well, the first one did decreasing to increasing, so you can say it either way, but f prime switches from decreasing to increasing, or vice versa. Again, you could have that in the other order, increasing to decreasing or vice versa. One thing I want you to notice, the graph that we were given was a graph of f prime. Notice how every single one of my justifications has f prime reference. I got it here, 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 and here. Always referencing what's given. Always. Don't just assume, right, that the other person knows what you're talking about. Okay, I'm going to go through this one just a little bit quicker because we're running out of time here. Critical points of f. Again, that's when f prime equals 0. Notice this goes from -6 to 5. It doesn't include -6 or 5. So even though this is a critical point here, I can reject it. X equals -2 is a local max because f prime switches from plus to minus. And x equals 2 is a local min because f prime switches minus to plus. Okay. Sorry, I don't know why this isn't scrolling down very well. Okay. B is kind of a new problem so far for this video. On what intervals is f both concave down and increasing? So I need to look for two things. F needs to be concave down and f needs to be increasing. So I'm going to start with increasing first. F is increasing when f prime is positive. So I'm only looking at the top part of the graph. Okay, I can ignore this semicircle down here. So just looking at the top part of the graph, now I'm looking for concave down. That, by definition, is f prime needs to be decreasing. So I'd say from -6 to -2. Union, I'm going to reject this part and look just for this part, 3 to 5. Okay? I'm running out of time here. For this one here, f double prime. When you're calculating f double prime on an f prime graph, you're treating it like the derivative of the graph we have, because the derivative of f prime is f double prime. Right? So we're looking for the slopes. But one of these two is undefined. Okay? The reason why f double prime of -2 is undefined, because I can't find the slope at this corner. Okay? F double prime of 4 isn't at a corner, so I can calculate this slope. It's just the slope of this line right here. But at any corner points, so here, here, and here, f double prime will be undefined. Okay, that's it for this video. Study hard. See you guys Monday. 2 chains. Bye.